Good morning, good afternoon, and good evening. Welcome to today's session on building blocks of modern data architecture. In today's discussion, we're going to talk about how different data organizations are revamping or rethinking their data ecosystem to meet the increasing demand on data-driven decision making. This is particularly true when you come to different data personas they have within the organization. My name is Arun Manian. I'm a senior solution architect specializing on data analytics and AML space within AWS. Prior to joining AWS, I spent majority of my career working for multiple enterprises, envisioning and implementing different data strategies. Before diving into today's session, I also want to let you know that throughout my deck, you will see some tools, technologies, frameworks. This is a very small subset of what's available on the market, and your specific need may require you to explore additional tools and technologies. And that's a due diligence that I would request everyone, you as a end consumer or end user, to make from your side. My role here is primarily to give you some principles or guardrails to help you make that final decision when it comes to revamping your data architecture. With that being said, let's dig into today's session. So for a long time, when you think about analytics as a capability, data warehouse used to be the status quo. And that's the case even today. There is no hard feeling there. Even today, for large and small enterprises, data warehouse meets a lot of their analytical needs, and that's perfectly fine. Over a period of time, what has happened is that there were multiple data warehouse built within their organization. That could be within their LOBs or departments, pods, however you call that within your organization. And what that ended up happening was a bunch of siloed data warehouses across different technologies that became even more difficult. And that's the current state where most of the big brand organizations having challenges when it comes to data warehouse related analytics. There are obviously a lot of benefits when it comes to data warehouse, right? So if you think it's unified and easier experience for end users, all they have to know is queries and then probably some dashboarding tools can get them to use the data fairly quickly. It's considered as a single source of truth, which is at least in principle what they promise to. The data is always standardized, clean, and pre-processed. So in that perspective, from an end user standpoint, all they have to do is to start analysis and don't worry about data quality, so standardization, any of those things. And there are many more. But that being said, we also spoke about some of the key disadvantages. Let's start with siloed, where as different departments started building their own warehouses, the visibility of these, the benefit they're seeing from their data warehouse was not fully transparent to the rest of the organizations. And that created kind of a larger distance within the organization. When it comes to data warehouse, everything has to be structured, right? So you need to have data models, you need to define what's facts and dimensions and third normal for. So there is a lot of work that goes behind in terms of spinning up an data warehouse capability for the end user. That resulted in a lot of cost. So if you think ETL is always the most expensive part, that starts with data profiling, making decisions on data modeling, and so forth and so forth. Other major challenges or concern we heard from a lot of consumers is that when it comes to adding something new to data warehouse, it was always lengthy. Right? Most of the times it will be stuck in a backlog for this fairly small data warehousing team they have in the organization. Or it's too complicated. They may have to do a lot more data analysis. Sometimes the data owners are not the people who are defining requirements, and that takes a lot of back and forth in terms of building that data model and making it available for the end users. Now, with the explosion of big data, that's where the middle layer of entire analytics has moved. So when we talk about large volume of data being generated through different devices, with different variety of data, with different value of the data, the concept of data lake has explored in the last several years, right? So if you were to ask me whether data lakes are successful, probably say 7-8 years ago, I would say no, they're still in a very niche stage. But in current world, data lake is solving a lot of challenges for end users. If you just compare and contrast this to the data warehouse, there is no need for anything to be structured. So that gives a lot of flexibility when it comes to using the data lake. From an end user perspective, there is a concept called schema on read. So you can bring the raw data as is, and then based upon your need, you can decide what kind of modeling you need to apply when you're reading the data. rather than spending a bunch of time in terms of modeling it in the first place. So that has made adoption of data lake much more prudent for a lot of the consumers. Initial data lake was primarily used for advanced analytics or dashboarding, and then from there it has exploded in the region of machine learning and finally embedding these solutions for the end applications. So it became operationalized to a larger extent. And this is all possible by having data lake providing this versatile functionality for the end users. That being said, there is also some drawback that came as part of the data lake implementation, and that's primarily called a data swamp. When different organizations started collecting and processing data, they pretty much took an approach of building their own data lakes. Probably there was less visibility of what's happening, and that ended up creating too many data swamps. And in the world of regulations, it is becoming a challenge. So that's the changing need that data lakes has to take into consideration as we go forward, right? And it primarily stemmed through regulations like CCPAs and GDPR, where you as a data owner or a data user have to take full control of what data you process or give access to, and meanwhile also respecting the privacy of customer. So CCPA's request pretty much says that if I as a customer want you to delete my data, you have to do it, right? So that's the kind of regulations that's been coming through. We also spoke about there are transactional or operational needs that's been stemming out of data lakes. And that requires something called a transactional data lake, where it can handle both reads and writes at the same time. And that's the concept called transactional data lakes that needs to be evolving. It's still evolving, but it's in a rapid pace. We also spoke this cycle of analytics to operations to analytics, right? So this is where you might have built some machine learning model using your data lake by analytics or predictive analytics. You found that there is an operational use case. For example, you have built an image recognition model. You can use that model to do, say, policy document validation. And then that has to be operationalized. And finally, that can create furthermore data, which can feed back into the analytics. And this is a cycle. So your lake should have an ability to, or your analytical platform should have that ability to morph between analytics and operational based upon the user demand. So that brings to the point of, for any modern data architecture, some of the key objectives that everyone wants to achieve is, first is unlock the value of the data faster, right? The concept here is that you may have gigabyte or terabyte or zettabyte of data sitting in your data lake or data warehouse environments, but there are frictions in terms of how you can access that data. The data can sit there without unlocking the value of it. And by the time you start, and if that takes a long time for them to start unlocking the value proposition of the data could be diminished over a period of time, right? So that's what your data platform should provide your consumers to quickly get insights your data, and that should be one of the key objectives. Second is it should be more agile and flexible in terms of decision making. If I make a decision to use my data in a particular way today, or with a set of tools and technologies today, you also know that the market in general is maturing every year or every month for that matter. So you need to have the flexibility to take your data, move to some other platform, and then probably get a better value out of it by just more. The third is to be cost effective. You don't want to spend a lot of money upfront, assuming you're going to get some benefit. But whereas you need to have a platform which can give you the flexibility of pay as you go or pay only when you use it. And finally, it has to be secure in the world of compliance and regulations. Security of data is prime importance. So the way how these platforms can honor your data security needs, like encryptions or fine-grained accesses, all these things has to be embedded as part of your data platforms. Now that brings to the key pillar of when you talk about when I make a decision in terms of what technologies or frameworks I need to bring in. These are the key pillars I want you to keep in your mind. First is called scalability. That's where you need to build the platform where it can scale. Data has gravity. That means once you start using data, there'll be more and more users. And that can exponentially change over a period of time. So build a platform that can scale based on your need. Don't just assume that you have 100 or 10 users today, it can become 100 tomorrow. It could be 1,000, right? Now, how can you make your platform scalable without spending too much of time or effort is something you need to consider as a key pillar. Second is reliability. So that's where you have to make sure that the data, once you made available for your consumer, they should be able to reliably get that every single time. That way they are not running into challenges, or they are not struggling to get the data when they're making progress in their analytics. Security is important, as we discussed earlier, like regulations, compliance, governance, everything needs security. So whenever you're building your platform, whether it is from storage to data movement to access, make sure that your platform honor the security requirements. And finally, it is all about operational cost effective. So and what that means is that sometimes you may have to think beyond your specific technology. Let's say you may think that storing a data on a data lake in its raw format can help with my cost. But then, and compute cluster can be too expensive to process the data, and that can become cost prohibitive at some point. When you say cost prohibitive, you may lose the benefit of cost efficiency if you're not picking the right frameworks and tools for that matter. So with that, let's talk about how the two major analytics platforms are handling these changes, right? Let's start with data warehouse. There, first is what we're seeing very, very prominent with many of the customers, that they're moving to cloud. Cloud adoption is becoming very, very lucrative for a lot of customers. They get the flexibility of pay as you go, don't have to worry about undifferentiated work like infrastructure management. So there is a lot of benefit by going into cloud as such. There is an explosion of SaaS offerings. If you look tools like Snowflakes or Redshift or BigQuery, the whole idea is that the SaaS providers will provide you a platform where all you as a customer is to think about is that just get my data. And a lot of the platforms is providing you the benefit, like you don't have to maintain the infrastructure. It has got intelligent AI built in the background to optimize your queries or optimize your storage or doing right partitioning, et cetera, et cetera. So there's a benefit that customers are getting by considering SaaS offerings as their data warehouse solution. There is an explosion of columnar data stores. Again, that's primarily going to help you in terms of improving your query performance. And finally, there's AI-driven predictive modeling or predictive monitoring. That's where there's a concept called self-healing, where based upon the data quality that's been automatically measured, your system can make self-healing methods, right? So it can do corrections on behalf of you rather than spending months in terms of making that correction. And that makes sure that the data quality is good for all the underlying applications and not fearing out, say, 2 months down the lane that there is a major quality issue and you restart your analytics. From a data lake perspective, one of the major things that we're seeing is data awareness. And this is where the concept of data catalogs and governance and cross-level sharing is coming to picture. There is a notion that storage is cheap on a data lake because it's all blob level storage, but then that's been overutilized by a lot of the consumers, right? So they will start creating their own data store by replications and all things. And that has resulted in data swamp for sure. But then the other major downside for that is that when it comes to governance, it becomes nightmare. Like you don't know which all consumer is using what kind of data set if it is not visible at an enterprise level or at a governance level. So data awareness is very important when it comes to how you need to handle the data lakes. Second is the concept of transaction data lake, where we spoke about data lake is now used for application use cases now, like your machine learning model needing inference at the end of the day, or for CCPAs where governance require you to delete records for a specific customer. Think about a scenario where we have billions of files or billions of records spread across millions of files, and one of your customers is asking you to delete his or her specific record from your data lake. That's extremely complicated because making the changes in a data lake on a file level or a raw data level is going to be extremely complicated. That's where table formats like hoodies and icebergs and govern tables are making headways in terms of how you should reimagine the data lake. Now, we spoke about data lakes and data warehouse meeting a lot of analytics requirements, but it is not just data lakes and data warehouse which is going to fill your ecosystem going forward, right? So there will be this concept of something called purpose-built data stores. So let's take an example of the operational use case we spoke about. You build a machine learning model using your data lake data set, and then you want to operationalize it for your end application. And for that end application, you may need millisecond response to come back from a data lake. And that's not possible all the time. It is achievable, not, but you may spend a lot more time or energy to make that happen. So that's where a key value data store can make a difference. So that's where, sometimes the data has to finally result in key value data store to make that final impact. Let's come back to the analytics use case one more time, right? So let's say if we have a log analysis that has to be done, where you have a corpus of documents or corpus of logs, and you want to do some analytics on top of it. Can you do it using data lake? Absolutely, yes. But you may have to spend a lot of time in terms of defining the right partitions or right methodology of data movements or data processing. A better solution could be to put in a search data store, like an elastic search data store, where it is tuned to do log analytics. So even from an end user perspective, they have dashboards rather than writing 100-line code to process their data set. Same can be applicable for your cache data stores, where you again need millisecond response rates or sub-millisecond response rates. You can have document DBs, relation data store, yada, 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 right? So you got the point that in the future data ecosystem, you will have purpose-built, or you need to plan for purpose-built data stores to meet the end goal of what end consumers will be looking out from your data landscape. These are some set of purpose-built data stores you see in the market. There are data warehouse solutions, search solutions, NoSQL solutions. Again, do your due diligence in terms of what makes most sense for you to bring in. But keep in mind that at the end of the day, you will have an ecosystem of data. The data has to move between these data assets. So are you getting locked with proprietary data sets or proprietary technologies? How difficult is for you to move data from one place to the other should be one of the deciding factor when you come to choosing some of these technologies. We spoke about data will be there in different data stores, and that means you need to have data movements, right? So data may have to move from data lake to a key value store or a search store. And this can happen in 3 different methodologies. It can be a batch-based processes or a real-time streaming or a near real-time streaming. So what does mean is that your platform should have, an ecosystem should have a platform which can enable ELTs and ETLs and data transfers with frictionless data transfers, right? So how easy and fast you can move data from one asset to the other. Do I need to spend 100 of hours to learn new tools compared to like if these tools are providing me connectors and it makes my life easier. These are some of the frameworks or tools that we see in the market making a major impact on for many of the customers. Again, due diligence, I wouldn't recommend one versus the other. Your specific need may be requiring you to pick one versus or a few based upon where we're heading, but then do the due diligence in terms of what makes more sense for your specific platform requirement. Now, the data is available in these multiple data stores. You need to have a layer by which your consumers can get access to it, right? So let's say your data is sitting in data lake, and then your consumer wants to do some data analytics on the log file. Sometimes, you may make a decision to move to search, but how do we make that decision? And that's where the consumption layer comes into picture. And in this area, what's picking up a lot is data virtualizations or federations or query engines or programmatic layers, where based upon the skill set of your persona of users, the consumption layer can abstract the complexity of data access. And that could be like in-place SQL query. So you can access your underlying, say, data lake by plain and simple query. You get some initial insights and then finally make a decision. Probably it makes sense for me to move this data to like a search engine, or the end goal could be like I can continue with the process of virtualization or federation, right? So your platform should have that ability where it can abstract the complexity of accessing data, especially when you're talking about data ecosystem having multiple platforms and technology in the background. This is an area where we're talking about dashboardings or virtualizations or in-place queries that's been spinning up. This is an interesting area. You can see a lot of new vendors or new softwares coming in to make this process easier for the end consumer. Now comes the interesting topic of AI and ML, right? So none of the analytics topics are complete today without the inclusion of AI and machine learning. And that's very true when it comes to, for the majority of the consumers. If you look most of the CEOs or CTOs are planning to have more machine learning or AI-driven solution making in their specific area so that they can get better value of the data that they have. Now it's a emerging state, but it's rapidly growing. In that sense, what we're seeing an uptick is something called an AI as a service. So big brand organizations like AWS or Google's or Data Robots kind of organizations are providing API layers where you can call a pre-trained model. So like natural language processing or image recognitions or speech recognitions, image classifications. So instead of your data scientist spending months or years to build that model, these organizations had made those investments to build these models and make generally available. So if you're doing some analysis, you're making a theory that probably machine learning with image recognition can bring X amount of revenue, but you're not sure about it. Before you spend that time to build that model, using an AI-based service can help you to at least test out the theory at a much faster rate. Now, that being said, we also know that a lot of the organizations are also very particular in terms of what kind of third-party AI services can be brought into the platform. And other thing is that some of these AI services may not meet all the requirements what your business user is looking for, right? And that's where your platform should have a region where you can do repeated analytics, unlimited analytics, or more number of machine learning without the friction of how can I get my infrastructure based upon my needs? So your platform should be scalable enough to meet those demands. The other concept we're seeing is community-based data scientists, right? So the data science as a concept is extremely complicated. You need to know algorithms, you need to know data, you need to know business. Now, to get all those skill set combined in one person is very difficult in the current market. So there are tools or frameworks which is providing a capability called AutoML. So the AutoML tools can abstract the complexity of algorithm selections, feature engineering, fit for purpose algorithms, and etc. And that is enabling a lot of data analysts to be working at a capacity of a data science or a data scientist. And that's what we're seeing with a lot of organizations picking up. We also said that there is an uptick in terms of how this AI landscape is changing. So things that is not possible today could be very well made possible by another vendor down the lane. So have your platform in such a way that you can take your learning from the current platform and move into a new platform and then transfer that learning and quickly start adopting the new platform for your specific use cases, right? And that's all about breaking the barrier. And one way it's achieved is that through the concept of decoupling, where you decouple your data, you decouple your application, you decouple your ETL processing or ML learning methodologies, and that can help you to make that leap based upon where the technology is heading. These are some of the frameworks or the tools or vendors who is leading in this area of machine learning, especially around AutoML capabilities and giving quick value for the end consumers. Now, all this conversation is not complete until we talk about governance. Let's say initially we spoke about the concept of data swamps and how it is impacting a lot of the enterprise in terms of not getting the right value, or probably not able to get the right value in the right place. And that's where the unified governance comes into the picture. And what this needs is that we need to have a central catalog where you can discover the data, you can share data. If you know this data that's available in some other place, and you have visibility to it, you can at least see whether you can share it rather than building it from the ground up. There should be technical metadata and business metadata that can help you to make that final decision in terms of data sharing or building something new, right? Finally, there should be an uniform access policies. So let's say one of the user cannot access PI information, and that should be common across all the data ecosystem you have. And it should be same for your data lake, it should be same for your search. So how can you apply that common access policies across all the data store? And that's what this unified governance will have to take care of. Finally, there is this concept of monitoring and controlling. How can I know who's getting access to what kind of data set? Can I revoke my access for a specific user if he or she is a bad actor? And then there's a concept of data lineage. And this is very important when it comes to compliance. Let's say you have data moved from data lake to, say, cache or to a search. But during that moment, the data entity has changed. So for example, the data was stored as first name and last name. And then in the search, it was written as full name. So the lineages will let you know that this is how the data moved. So essentially, these two data are same. So when it comes to, say, compliance to delete the records or update the records, this lineage will help you to get to that quickly. Now, in all practical sense, in the governance or central governance is not like you can do everything centrally. This is the practical implementation where this concept of data domains. And this is very true in terms of how data mesh architectures are evolving everywhere, where each of the data domain will maintain their own governance and they will contribute to the central or unified governance. And there is a tight coupling between these two teams. And that's how you can make your data enterprise level accessible, but then also putting guardrails in terms of what kind of data set can be made available by the data owners for a broader use case. These are some of the areas where a lot of innovations are happening. It is very critical for a lot of the industries. So keep an eye in terms of how this whole area is changing. So let's bring all together, right? So for your modern data architecture, we should start with considering the right data stores. It should be fit for purpose stores so that you get better price performance, and it gives you improved customer experience. You should have a process by which the data can move between these data stores, and the more frictionless it is, the better, right? The more connectors you have versus custom coding, that's better. That makes your user experience even better, right? So that's what we have to consider when it comes to efficient data movements. Ease of expression, that's where we need to help customers to, or your end consumers to get access to data quickly with ease, right? So it should be given by how can you honor the skills that they have and still provide that kind of access. And most of the power users may be using SQLs or Pythons or any of these tools. And how can you make that available for the end users? So that's the ease of expression through virtualization or federation that need to be considered. A need for a robust machine learning model where you can transfer learning, the concept of auto ML or enabling eligible data analysts to be data scientists, that's also another building block that we should consider. Everything should be wrapped under the concept of central governance. That's where you can enable ease of discovery. It should be expandable. So as the technology is changing, how the governance tool can quickly take those new tools or technologies and integrate. That's critical. So when you're picking up a vendor or a software, look into their roadmap. What is their concept? Are they only going towards a specific tools or technology versus going in a broader sense? And that's how you're going to future-proof that at the end of the day, the governance can be centralized by that infinite scaling, but also you're not getting bogged down in terms of how that value can be made. And all this should be under the premise of all the tools and technologies and framework should be scalable, secure, reliable, and cost effective. So keep that in mind when you're making the decision in terms of how should I revamp my platform. So that's it from my side. It's a wrap. You can get in touch with me through my LinkedIn profile. I hope that you learned something new and you enjoy the rest of the session that's planned for you today. And hopefully I'll meet some of you through LinkedIn or at some point in person. With that, I'm going to wind up my session. You all have a wonderful day ahead. Thanks.